Today's lesson is Chapter 10, Lesson 7 on pages 745 through 750. Our objective is I can multiply mixed numbers. Question 1. The first step in multiplying mixed numbers is to change the mixed number into a blank fraction. Question 2. When you finish multiplying the fractions, you need to change your answer back into a blank number.
Multiply 1 3/4 times 7 1/5. Simplify your answer and write it as a mixed fraction. So the first thing we want to do is rewrite each of these mixed numbers as improper fractions. It's very difficult, or at least it's not easy for me to directly multiply mixed numbers. One can do it, but it's much easier if you just make them improper fractions. So let's convert each of them. So 1 3/4. 1 3/4 is equal to, it's still going to be over 4, so you're still going to have the same denominator, but your numerator as an improper fraction is going to be 4 times 1 plus 3. 4 times 1 plus 3. And the reason why this makes sense is 1 is 4/4, or 1 is 4 times 1/4. Right? 1 is the same thing as 4/4, and then you have 3 more fourths, so 4/4 plus 3/4 will give you 7/4. Will give you 7/4. So that's the same thing as 1 3/4. Now let's do 7 1/5. 7 1/5. 7 1/5. Same exact process. You're still going to have, we're going to still be talking in terms of fifths. That's going to be the denominator. And you take 5 times 7, because think about it, 7 is the same thing as 35 fifths. So you take 5 times 7, so it's 5 times 7 plus this numerator right here. So 7 is 35 fifths, then you have 1 more fifth, so you're going to have 35 plus 1, which is equal to 36 fifths. So this product is the exact same thing as taking the product of 7 over 4 times 36 over 5. Times 36 over 5. And we could multiply it out right now. Take the 7 times 36 is our new numerator, 4 times 5 is our new denominator, but that'll give us large numbers. I can't multiply 7 and 36 in my head, or I can't do it too easily. So let's see if we can simplify this first. So both our numerator and our denominators have numbers that are divisible by 4. So let's divide both the numerator and the denominator by 4. So the numerator, we can divide the 36 by 4. We can divide the 36 by 4 and get 9. And if you divide something in the numerator by 4, you have to divide something in the denominator by 4. And the 4 is the obvious guy. So 4 divided by 4 is 1. So now this becomes 7 times 9. And what's 7 times 9? It's 63 over 1 times 5 over 5. So now we have our answer as an improper fraction, but they want it as a mixed number, or as a mixed fraction. So what are 63 fifths? So to figure that out, let me pick a nice color here. We take 5 into 63. 5 goes into 6 one time. 1 times 5 is 5. You subtract. 6 minus 5 is 1. Bring down the 3. 5 goes into 13 2 times, and you could have immediately said 5 goes into 63 12 times, but this way it's at least to me it's a little bit more obvious. And then 2 times 5 is 12, and then we have, 2 times 5 is 10. 2 times 5 is 10. It tells you not to switch gears in the middle of a math problem. 2 times 5 is 10, and then you subtract, and you have a remainder of 3. You have a remainder of 3. So 63 fifths is the same thing as 12 wholes and 3 left over, or 3 fifths left over. And if you wanted to go back from this to that, just think, 12 is the same thing as 60 fifths, or 60 over 5. 60 over 5 plus 3 over 5 is 63 over 5. So these two things are the same thing. These two things are equivalent. This is as an improper fraction. This is as a mixed number, or a mixed fraction. But this is our answer right there, 12 3/5.
All right, so let's look at a problem in our book. I'm on page 745. So in this problem, it says the recipe calls for 1/2 cup of blueberries And the blueberry pie recipe calls for 3.5 times more blueberries. So how many cups of blueberries are needed? So we know it's a multiplication problem then. So it's 1/2 times 3.5. So we can shade the squares that represent the product is one way, or we can also work this out in the way that we learned about in the video. So if we have 3.5, the first thing we're going to do is turn 3.5 into an improper fraction. So 3.5 is the same as 3 halves, right? Well, 3.5, we have to multiply it into halves because 1 whole would be 2 halves, or 2/2. So we need to multiply 3 times 2 to figure out what it's equal to. So 3 times 2 gives us 6 halves. And then if you look at that, and if you remember that the fraction line is the same as the division line, 6 divided by 2 is 3, so we know that's equal. But then we had one other half here that we had to add in. So even though we multiplied 3 times 2, we have to add in that numerator on the top. So we have to add in 1. And then our improper fraction for 3.5 will be 7 halves. Okay, so then I went ahead and wrote our multiplication problem here. So we have 7 halves times 1/2. So remember, just multiply across. 7 times 1 is 7. 2 times 2 is 4. And now we need to turn this improper fraction back into a mixed number. So we can think about 7 divided by 4. So 4 goes into 7 once, and then there are 3 left over. So 1 3/4 would be our product. And then I'll show you what they were talking about with this shading up here. So they have 3.5, so think of this as a whole, this box as a whole. I'll draw an extra line over there. That's 1 whole. This would be 2 holes. This would be 3 holes. And then this is half of a hole. So that gives us 3.5. Then this vertically is half of the recipe. So if they shaded 3.5, they shaded this part, it would give them a picture that looks like this. And what they did was just reorganize the shaded part so that it could fill up holes. So now it filled up 1 hole, because remember those 4 boxes were 1 hole in our picture. And then it has a little bit more. So it fills up 1 hole and then 3/4. So really, if we're looking in terms of fourth, each of these squares being 1/4 of the whole, because there are 4 boxes in it, so 1/4. We have 7/4 shaded. So remember, there's 1 hole in there, and then there's 3/4. So that 7/4 is the same as 1 3/4. All right, look back at these 2 questions and answer them in the form, please.